We'll start with the notion of differentiability and why it's important, and a few examples of it. You have learned quite a lot because you have done derivatives in your entire high school, 11, 12, not probably in the 12th standard, and you know about derivatives like a lot.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
We will be devoting our time to understand the differentiability of functions and what are applications. Let's start. So first step is the notion of differentiability. The why differentiable is important because we will see as we proceed that if we know the derivative of a function, so derivative is nothing but it's locally linear approximation of a function. Like for example, if there's a, let's say you have a graph of a function, and so you understand locally this function behaves like this line. If we ask that what is the derivative, like sorry, what is the slope, so this line is uniquely defined by its slope and intercept, right? So if I ask you what is the slope and intercept of this line, how do you know that? So that's the question derivative is trying to approach. Okay, so if this line is locally behaving like a linear function, which it does, so why it does, if you take a smooth curve, let's say any smooth curve out there, let's say if you take this bottle out there, so this locally you can approximate it like a plane, let's say like this, right? So what is, so how do you define this plane locally? You can see it touches like at a simple point at this point. So what is this, like how do you define this? So there's a unique number to it, right? If we know the function well, fx, how it's related to that. And that's the whole purpose of bringing the derivatives, okay? To make you understand the local like approximation of function by a locally linear approximation of function. Locally means it happens at every single point, let's say x naught comma 0. So this height is nothing but, if this function is fx, this height is nothing but, this point is nothing but x naught comma f of x naught, right? So he's asking that for the function, what is the, so question is that at x naught comma f of x naught, what is the best linear approximation of fx? This is the question we are trying to solve. And it's solved by this simple method using limits. It's done by Isaac Newton. So it's very simple. Let's say you take this x naught comma 0. So it's what he has done is this, that if you take a small h, like x naught plus h comma 0, and the corresponding height will be this. So this point is x naught comma f of x naught, and this red point is nothing but x naught plus h comma f of x naught plus h. And what Newton told that, see, this local approximation can be found out by a series of approximations by a limiting format. How? So if you take this blue line now, joining these 2 points, and observe that as you, let me try out this thing. Just give me a minute. I'm trying out something. I don't know whether it will work or not, so that it's graphically visible to you. So, so let me see if it works. Probably it works. Yeah, just like a visualization purpose. If this is x naught plus h comma 0, so this is x naught comma f of x naught. This is x naught plus h comma f of x naught plus h. And you can see that the Newton told that if you move this red curve and move this, if h becomes closer to 0, okay, then you see this probably at this limit, it will be this line. That what it's telling, okay, telling you. So Newton defined that the slope of this line. Why the slope? Because if you see this, if you take this point, so what we have right now is the following, that so this is the new line. So observe this, that this point is x naught comma f of x naught, and this point is x naught plus h comma f of x naught plus h. And if you see that f of x naught plus h minus f of x naught by x naught plus h minus x naught, if you remember coordinate geometry, this is nothing but so this height is nothing but this, and this height is nothing but this, length is nothing but this. So therefore this is nothing but the tan theta. Okay. The you can say theta of h. Oops. You can say theta h. It is theta of h, tan theta of h. H means depends upon h. So tan theta is nothing but the slope of this line. You know that, right? Um, so it's nothing but slope of line at joining let's say P and Q, Q of P and PH, let's say P and PH. Now, what Newton told, that if limit h tends to 0, so you can do it from left hand side. You can also do it from when h is negative, it's left hand side. Okay, when h is negative, this is left hand side. So h tends to 0. This f of x naught plus h minus f of x naught, f of x naught plus h. Sorry, x naught plus h minus x naught. This is some number. If this limit exists, they define at f dash x, which is nothing but, and you can see it makes sense. It is slope of the. That's how we define slope of the line joining P and the line at of slope of the line tangent at P. That's his definition. This is how we defined it. It came from intuition, right? So this is what he observed, and he came from intuition, and he defined it as this. Okay, so as I said, 0 means pH is going towards, or rather, you can also say that is pH is going towards P. So this slope of the line, so therefore that it will be going towards the tangent at P. Okay, it's very easy, and you can understand that. But the basic idea is that both limit must exist. That means, so essentially differentiability is nothing but a limit problem. So therefore f of x plus h, x naught plus h minus f of x naught by x naught plus h minus x naught is this, and also it must be this plus will be equal to limit h naught minus also. It's coming from minus side. This must be equal to whatever single number, that number is called f dash x. So a counter example, it's like very easy example. You can take any example out there. It's like, let's say f(x) is equal to x square. So f of, let's say you want to find x naught plus h minus f of x naught by x naught plus h minus x naught. This turns out to be limit h tends to 0. This turns out to be x naught plus h whole square minus x naught square by h, limit h tends to 0. So this turns out x naught square cancels out. So it turns out that twice x naught h plus h square by h, limit h tends to 0. And it turns out that it's nothing but twice x naught plus limit h tends to 0, 0, h tends to 0, h square cancels out, and therefore it's 0. So it's twice x naught. So f dash of x is twice of x. Okay, that's how it's defined. Simple stuff.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.